Hello Stella, welcome back to these tutorials. Um, so today we are to see, let's go into the evolution. We are going to see some integrals of rational functions that will give rise to inverse trigonometric functions. That is, when after integrating them, you always see that in their answers there will be things like arcsine of something, arccos of something, arctan of something. You understand? Now, these are the examples, these are the exercises. I think if you try to do them, you have a perfect mastery of this type. Basically, you can put a pause. You can put a pause now on the video and try to exercise yourself on these exercises. So, okay, what I will do, I hope you made a pause on the video and you tried yourself these exercises. So what I will do today is I will do this first one, this step one, the fourth one, and this last one, just to illustrate some important things. So let's go directly into the job. So let's do the first one. We have the integral of x plus 1 all over the square root of 1 minus x squared. Okay, dx, indefinite integrals. Okay, exercises. This is F exercises. Okay, the first one we are to integrate integral of x plus 1 all over the square root of 1 minus x squared dx. We are to integrate these exercises. Let me verify. Okay, let's get into stuff. Okay, we are to integrate this. Okay, let me first try to observe this. When I differentiate this bottom, if I differentiate it implicitly 1 minus x squared, when I differentiate this one, I'll have 0 times dx. Now, I differentiate this one, I'll have minus 2x times dx. Is that okay? Now, but at the bottom, we are not saying this minus 2x. We are instead seeing an x. Okay. I'm sure you must be asking yourself, how are we then going to integrate this? How are we going to proceed? This is very simple. Look at something. I told you in a previous video that if you have a plus b minus, let's say g, on the, let's say alpha, this is the same thing as what? A on alpha plus b on alpha minus g on alpha. I told you this. So I'll apply this to this integral. This becomes integral of what? X divided by the whole of this. X divided by what? The square root of 1 minus x squared dx plus the integral of what? 1 all over the square root of 1 minus x squared. Very good. Okay, let me wipe this. Okay, so this will be equals to this. Let me wipe this. Okay, now there is something important I want to tell you here. Whenever you are in an exam, you saw previously that we saw previously how to integrate 1 minus x squared, integral of minus 1 all over 1 minus x squared, and integral of what? 1 all over 1 plus x squared dx. Let me tell you now, I can recall that in the videos where I gave you the answers of this. I reminded you to remember this integral and remember their answers. This is where it will become very important now. Whenever you are in an exam, if they don't ask you, prove this. If you are not asked to prove this, if you see an integral which is simply in the form 1 minus integral of the square root of 1 minus u squared, I'm not saying that if you see this, let's say 1 minus x plus 1 squared dx, you just give the answer no. If you see something of this form, 1 minus a variable square, you have the right to just say that, recall that this integral is equals to what? Arc sign of what? Of that variable. You have the right to say that. There is no need of wasting time and doing the substitution. Let sine theta be no. There's no need. This is where those formulas will help you, will come in. You understand? So, like for example, if you can remember, there is an example. Let me go back before continuing this video. Let me go back to that example. Where is it even? Solving. All right, very good. We did this integral. There is an integral we did. Let me go back. Where is it even? Okay, there is this integral we did last time. I think it was something 2 or 3 videos before. We did this integral where I showed you that it was possible to do this integral with 2 substitutions. You understand? Look at something at this level. When you reach this level, look at something. When you reach this level, I did not say that this integral is direct. I did not say directly that this integral is equals to arctan something times something outside here. No. I said whenever you are in a situation where you just have 1 plus u squared, there is no need of saying that let tan theta be this. No need. Just recall. Just say that. Recall that this integral is equals to what? Arc tan of u. The same thing for sine. If you have integral of 1 all over the square root of 1 minus u squared, just u, or just x squared, just recall directly that it is equals to arctan. If you are in an exam and they ask you to prove this, that's where you will say let tan theta be equals to this. I hope you get what I'm saying. Now let's go back to what we were doing. Let me go to that slide. Where is it? Wait a minute. Okay, we're here. Now I'm going to calculate this integral and this integral. I'll call this star. Let's call this star for our work to be very organized. Okay, let's find this first integral. Find the integral of x all over what? The square root of 1 minus x squared dx. Okay, now what do you see? You see that if I differentiate this, if I differentiate implicitly 1 minus x squared, this will be equals to what? Minus 2x dx. Is that okay? That means, but at the top here, you're already having what? An x. This means if I substitute, if I multiply this integral by minus 2 at the top and at the bottom, this will help me. It will help me. We are going to have this part at the top. Is that okay? So I'll have the integral of, let me write this, the integral of x all over the square root of 1 minus x squared dx will be equals to what? Will be equals to, let's multiply top and bottom by minus 2 on minus 2. Integral of what? X all over the square root of 1 minus x squared dx. Very good. So this will be equals to minus a half. This minus 2 will enter. Integral of minus 2 dx all over the square root of 1 minus x squared. Now, we can already recognize this as this, but I'll not recall, but d of what is inside here, 1 minus x squared is equals to what? Is equals to minus 2x dx. This implies, I'll copy all of this, minus a half integral of minus 2x dx all over the square root of 1 minus x squared will be equals to what? I replace minus 2 dx. In fact, we are already in this form, the integral of f prime of x dx all over what? F to the n. Because this 1 minus x square root can be written as 1 minus x square raised to the what? A half. Are you okay with that? Okay, so this will be, I'll put this in this form. This becomes minus a half integral of what? D of 1 minus x square all over what? 1 minus x square raised to the what? To the half. So I'm already in this form, integrating something of this form. So this will be equals to a minus a half integral of what? 1 minus x square raised to the what? Yes, 1 minus x square raised to the minus a half d of what? 1 minus x square. So it's, if you look at this as a big X and this as a big X, because this is identical to this, it's like you are integrating big X to the n d of big X. It's like you are integrating this. And how do you integrate this? This is simply x plus 1, n plus 1 all over n, x to the n plus 1 all over n plus 1 plus a constant of integration. So this will be equals to minus a half times what? Since, as I said, since this is the same as this, we integrate this in this form. I hope you remember your lectures. So this will be equals to x to the what? 1 minus x squared raised to the minus a half plus 1 all over minus a half plus 1 plus what? A constant of integration c1. Okay, wait a minute. Let me create new pages. This is 48, 49. Okay. 45. Okay, so we are here. So this implies the integral, the integral of x all over the square root of 1 minus x squared dx will be equals to what? This 1 minus a half is a half. You understand? So this half, since it is 1 on a half, it will become 1 on a half will become 2. So this 2 will cancel this 2 and we'll be left with minus, this is 1 plus this gives a half. So minus square root of what? 1 minus x squared plus the constant c1, where c1 belongs to what? R. So we'll finish with this integral. Let's go now to the next page and calculate what? This integral. So finding integral of what? 1 all over the square root of 1 minus x squared dx. So by identification, I told you, if the exercise was to find this only, if the exercise consisted of finding this only or proving it, you will let your sine theta be equals to, because the substitution here will be sine theta equals to what? What is all square? That is x. You understand? But since we are in an exercise here where part of the integral is to find this, there is no need of wasting time and calculating it. There's no need. If you want, you can do it, but there is no need. So by identification, the integral of 1 all over what? Square root of 1 minus x squared dx is equals to what? Arc sine. I told you it is only when it is in this form that you have to directly identify it. If you were instead finding the integral of some, let's say 1 all over, let's say 1 minus x plus 1 squared, naturally what you will do, you will let your sine theta be equals to what? X plus 1, and you integrate and you proceed as we usually do. You understand? So it's very important for you to take note of that. So the integral of this by identification is equals to arc sine x plus our constant of integration c2, where c2 belongs to the set of real number. So it then implies the integral we're finding, x plus 1 all over the square root of 1 minus x squared dx, will be equals to what? Our first answer, our first integral we had is what? This minus square root of 1 minus x squared plus a constant c1. So this will be minus the square root of 1 minus x squared plus the constant c1 plus this integral. This gives arc sine of x plus the constant c2. But I told you these two constants, they are real numbers. So there is no need of writing two constants. This implies the integral of x plus 1 square root of 1 minus x squared dx will be equals to what? These two constants, I'll resume them to one constant k. So this will become square root of 1 minus x squared plus arc sine. Don't forget that arc sine is the sine inverse of x. Arc sine of x plus our constant of integration k, where k belongs to the set of real number. So that's our integral. That was simple, very simple. So you see that it resulted in this part of the integral that resulted in what? In an inverse trigonometric function. Okay, let's move to the next exercise. Let's move to the next exercise, which is, what is it even? The next one we have to do this, the integral of x minus 3 all over the square root of 1 minus x squared. Okay, so let's integral of x minus 2 over the square root of 1 minus x squared. So that's question 3. Question 3, integral of x minus 3 all over the square root of 1 minus x squared dx. You see that if you differentiate this bottom implicitly, what do you have? Implicit differential of this will be equals to minus 2x dx. But at the top, you are having what? X minus 3. You see that there is an x here, but this 3 is complicating our life. So we shall use the same approach as previously. We shall write back this integral as what? Integral of x all over 1 square root of 1 minus x squared minus what? Plus integral of what? Minus 3 dx all over the square root of what? 1 minus x squared. Very good. I'll not waste time in calculating this. In the previous exercise, we saw how to integrate this. Where is it? Where is it even? Let me go back to the previous page. You see that it's the same integral here that we just calculated. So you just come back to this video and try to go over it. So when integrating this, we saw that our answer was what? Minus the square root of 1 minus x squared plus c1. So I'll just copy that. I'll no more waste time in calculating it. So finding what? Finding integral of x all over the square root of 1 minus x squared dx. But you have to calculate it if you are in an exam. So from question 1, we saw that the integral of x all over what? The square root of 1 minus x squared dx. For the previous exercise, we saw that it was equals to minus the square root of 1 minus x squared plus a constant of integration. Let's call it c3. Now, let's integrate this, finding the integral of what? Minus 3 dx on what? On the square root of 1 minus x squared. Okay, very good. Now, this integral, the integral of minus 3 dx all over the square root of 1 minus x squared is the same thing as 3 into the integral of what? Minus 1 all over the square root of 1 minus x squared dx. What do you notice about this part, this integral? What do you notice about this integral? We know that this integral simply gives what? Arc cos of x. This is simply arc cos of x. If you can recall your formulas, you understand. So by identification, since you are not asked to prove this, since you are not in an exercise where they said prove this or calculate simply this, there is no need of wasting time. If you want, you can show all the working where all this comes from. You know that your substitution here will be what? Cos theta being equals to what? X. So by identification, the integral of minus 1 on the square root of 1 minus x squared dx is equals to what? Arc cos is equals to arc cos of x. Is that okay? So it implies integral of minus 3 dx all over the square root of 1 minus x squared will be equals to what? Minus 3 times what? Minus 3 times arc cos of x plus the constant of integration c4. So it implies our integral, the integral of x minus 3 all over what? The square root of 1 minus x squared dx will be equals to what? What was the first integral? The first integral we had was minus square root of 1 minus x squared minus the square root of 1 minus x squared minus 3, then this other integral, minus 3 arc cos, there's a c here, arc cos of x plus c3 plus c4. I'll group all this into a constant k, which belongs to r. You can precise here c4, always precise it belongs to r, and c3 belongs to r. Don't never forget it. You have to mention to the examiner that, in fact, you have to precise to the examiner any constant you bring in. So this implies the integral of x minus 3 all over the square root of 1 minus x squared dx will be equals to minus square root of 1 minus x squared minus 3 arc cos of x plus our constant k, where k belongs to r. So that's the integral you were asked to look for. So that's basically the integral you were asked to look for. Let me go to the next question, the next exercise, which is this integral. The integral of 1 minus 2x all over 3x squared plus 4. Okay, 1 minus 2x over 3x squared plus 4. That's question 4, I think. Yes, question 4. Question 4. Let me go to the next page. There's no more enough space here. So question 4, integral of 1 minus 2x over all over 3x squared plus 4, all over 3x squared all over 3x squared plus 4 dx. Okay. When you look at this bottom, if you differentiate this bottom, what do you have? If I differentiate this bottom implicitly, I have differential of 3x squared plus 4. When I differentiate this, I'll have 6x dx. This one, when I differentiate this, it gives 0. So 0 times dx will be 0. So you basically have 6x, but there's already this minus 2x. That means if we multiply top and bottom by 3, we're going to have this 6x. You understand? Minus 3, we're going to have this 6x. But the problem now will be this one. If we multiply it by minus 3, that will change, the thing will still be complicated. Where the exercise will still be a bit complicated because of this one that's here. So we shall use we shall proceed. In order to simplify things, I'll write back this as well. We shall use our rule, which says if you have a plus b minus c all over, let's say d, it is the same as a on d plus b on d minus c on d. Is that okay? So that's what you are going to do. Okay, I'll write this back as the integral of what? This 1 divided by the whole of this 1 all over 3x squared plus 4 dx minus 2x dx integral of what? 3 all over 3x squared plus let me leave this minus inside, plus 4. Okay, that's it. Now we shall calculate this integral and we calculate this other integral. Is that okay? Let's start with this first one because it will be very easy to calculate before going to the last one. That will take us a lot of some time. Okay, finding the integral of minus 2x dx all over 3x squared plus 4. Okay, we see that if you differentiate 3x squared plus 4 implicitly, you have 6x dx. Is that okay? When you differentiate this, you have 6x. Since you are differentiating with respect to x implicitly, you multiply by dx. And here, when you differentiate plus, when you differentiate this gives 0 times dx 0. Okay. Now, but the problem is that at the top, we have already our x and dx. The problem is bringing this 6. For us to have this 6, we need to multiply what? The top and bottom of this integral by what? Minus 3. So the integral of minus 2x dx will be equals to what? 3x squared plus 4 being equals to what? Minus 3 on minus 3 integral of what? Minus 2x dx. And remember, I told you you have the right to multiply an integral by real numbers but not by variables. So be very careful. I don't want to see things where you multiply top and bottom by minus x. You don't have the right to do that. Only real numbers. So all over 3x squared plus 4. Very good. So this will be equals to minus 1 on 3 integral. I'll bring this minus 3 inside and we multiply this. We have 6x dx all over what? 3x squared plus 4. Very good. Now we see basically that we have already this 6x dx. So I will say, but d of what? The bottom 3x squared plus 4 is equals to what? 6x dx. So I will replace this 6x dx by this. So it implies I copy the whole of this minus 1 on 3 integral of 6x dx all over 3x squared plus 4 will be equals to minus 1 on 3 integral of what? D of 3x squared plus 4 all over what? 3x squared plus 4. Is that okay? Now you see that this one is already like, it's already in the form, it's like we are integrating, because this what is inside here is what is inside here. It's like we are integrating 1 all over a big X. The big X is this d of what? Big X. And what is the integral whenever you have this? This is simply ln of the absolute value of x. You understand? So this will be equals to minus 1 on 3 ln of what? The absolute value of 3x squared plus 4 plus our constant, let's say c1. So it implies, so what were we finding? We're finding the integral of minus 2x dx. We're finding the integral of minus 2x dx over 3 x squared plus 4. So it implies integral of minus 2x dx all over 3x squared plus 4 will be equals to what? Minus 1 on 3. I did not precise here that c1 belongs to r. Always precise it. Minus 1 on 3 ln of the absolute value of what? 3x squared plus 4 plus c1. So we have already the first integral. Let's do the next one. We have to find integral of 1 all over 3x squared plus 4. Very good. Okay, so we are to finding the integral of 1 all over 3x squared plus 4 dx. When you see, if you are to integrate this, this is identical to what? Finding the integral of what? A plus what? Bx squared. And we know naturally that what will be the substitution here? Our dx. The first thing we will have to write it in this form. Integral of 1 all over what? 1 plus something all that squared, such that we let tan to be equals to what is inside here. Is that okay? So let's first rearrange this. So the integral of 1 all over 3x squared plus 4 dx is equals to what? The first thing is what we have to create. Be very careful. Write this back in this form first. The one is not, we are not supposed to create one. We are not, the first step is not to create one here, but instead here. So I'll first say it is equals to 1 all over what? 4 plus 3x squared. Is that okay? Dx. So we first have to create what? 1. We have to create a 1 here. So this will be equals to what? Let me take an eraser. So this will be equals to the integral of what? 1 all over what? I factorize 4 into 1 plus, since there is no 4 here, I write 3 on 4x squared dx. Is that okay? So this will be equals to what? 1 on 4 integral of 1 all over 1 plus 3 on 4 x squared dx. The next thing we have to do is what? Remove all what will be outside here and bring it inside this for all of this to be what? Square. Okay, I told you. So what we have to do is that we first have to write this to square. We first have to write it in this form. That is for us. So we first have to write this to have a square in order to easily bring it inside. You understand? And I told you the technique we usually use is what? So this will be equals to 1 on 4 integral of what? 1 all over 1 plus, you write this square root all that square. So I'll have square root of 3 all over 4 all that square, because this square will remove back this and come back to this times what? X squared dx. Now things are already very simple. This will be equals to 1 on 4. You see that? Take note of something here. If this integral was instead, if we were simply asked to integrate 1 plus x squared, I will not waste time. Since it's an exercise, if I'm not asked to prove this, if I notice that in an exercise I have to integrate this, something of this form, if I'm not asked prove this, if I notice that in an exercise while doing an integration, while finding part of an integration, I'm faced in a situation where I'm to find this, I would just say by recognition this is equals to what? Arctan of x. But here we cannot say that because we have a number here, we have another number here. You get what I'm saying? Okay, so you have to show the whole working. So this will be equals to the integral of 1 all over what? 1 plus, since this and this are having the same power, this becomes x square root of 3 on the 4. But I'll simplify this. The square root of 3 on 4 is the same thing as the square root of 3 all over the square root of 4, which is root 3 on 2. So I'll simplify that. So let me take an eraser. So this will be equals to x square root of 3 on 2 all that square dx. Very good. So I'll continue on this side. Let me wipe this. So you clearly see that things are already in the form what? 1 plus something all that square. So we can already do our substitution. So let tan theta be equals to what? We shall let tan theta be equals to x root 3 on 2. Will be equals to x root 3 on 2. So we see that where we are going to see x root 3 on 2, we shall substitute with what? Tan. And what of the dx? To find the dx, we simply have to differentiate what? This implicitly. So when I differentiate this, I told you the derivative of tan theta is what? Sec squared theta, or 1 plus tan squared theta. Since I differentiated with respect to theta, I will hide here d theta. When I differentiate this, I will have root 3 on the 2 times what? Dx. So this implies my dx will be equals to what? 2 into 1 plus tan squared theta d theta all over what? All over the square root of 3. Is that okay? So we have already our dx. So we substitute everything in this last integral we had. So this implies 1 on 4 integral of 1 all over 1 plus x root 3 on 2 square dx will be equals to what? 1 on 4 integral of what? We replace our dx. What is my dx? My dx is 2 into 1 plus tan square theta d theta all over what? All over root 3. My I will replace also the bottom. So I will have 1. This, what is inside here, is equals to what? Tan theta plus this, when you square it, you have plus tan square theta. So you see that this root 3 will come under here. So you basically see that this and this will go. So we will be left with 1 on 4 times what? 2 on root 3 integral of what? This d theta. Is that okay? So this will be equals to, these two will cancel this and we'll be left with 1 on 2 root 3 integral of d theta. The integral of d theta is simply theta plus our constant of integration, let's say c2, where c2 belongs to r. When you have already mentioned one time to which set your constant of integration belongs, there is no need of precising it under again. You understand? So, but recall, I told you that when you are integrating something in terms of a variable, you always have to give your answer with respect to the starting variable. But recall that our tan theta was equals to what? X root 3 on 2. Is that okay? This implies theta will be equals to what? Arc tan of x root 3 on 2. So it implies this integral we were finding, the integral of 1 all over 3x squared plus 4 dx will be equals to what? I just take this theta and substitute it where? Here. So I will have 1 on 2 root 3 arc tan of x root 3 on 2 plus the constant of integration c2. Okay, we have already found the two. We have already found the two integrals. So this was the first answer. So the integral we were finding was the integral of 1 minus 2x on 3x squared plus 4. Okay, very good. Let me go down. So let's go on the next page. So it implies the integral of what? 1 minus 2x all over 3x squared plus 4 dx would be equals to what? We copy the first one. The first integral we had was minus 1/3 ln of the absolute value of 3x squared plus 4 minus 1/3 ln of the absolute value of 3x squared plus 4 plus this one 1 on 2 root 3 arctan of x root 3 on 2 plus 1 on 2 root 3 arctan of x root 3 on 2 plus c1 plus c2. You know that, as I always tell you, these are constants. There is no need of writing these two constants. This implies the integral of 1 minus 2x all over 3x squared plus 4 will be equals to what? Minus 1/3 ln of the absolute value of what? 3x squared plus 4 plus 1 on 2 root 3 arctan of x root 3 on 2 plus a constant k of integration where k belongs to r. So that's our integral. So you basically see that, as I was saying, such integrals will always have part of the answer which is in terms of what? Inverse trigonometric functions. I hope that's okay. Okay, let's do the last question. This video will last a bit long, but there's no problem. Let's do this last one. Integral of 1 all over the square root of 6 minus 6x minus 3x squared. Okay, we have that's question 5. Integral of 1 all over the square root of 6 minus 6x minus 3x squared dx. Okay, that's let me check it first of all. Okay, it's okay. Let's now proceed to the integral. How are you going to integrate this? The first thing to do is to, this is a quadratic equation. The first thing to do is for you to first of all see if you can. The first thing to do is for you to first of all see if you can if this one is factorizable or it's not factorizable. Basically, you have to verify, you have to calculate delta of this, what is inside. So the first thing I will do is that let's calculate delta, which is equals to b squared minus 4ac 4 minus 3x squared minus 6x plus what? Plus 6. Let's calculate delta. Okay, our delta here is equals to what? Our delta here will be, which is equals to b squared minus 4ac, will be equals to, our b is what? Minus 6. Minus 6 squared minus 4 into, our a is minus 3, and our c is what? 6. Our c is 6. So this will give 36. This will give, okay, the first thing I'll even do here, this is even going too far. the first thing I will do here is what? You see that there is 3 that's common here. So this integral is the same thing as, I'll factorize the 3 because I don't want to deal with big numbers. So this will be equals to 1 all over what? The square root of 3 into 3 minus 3x, no, 2 minus 2x minus x squared. Is that okay? Dx. So dx, this will be equals to what? 1 on root 3 integral of what? 1 all over the square root of 2 minus 2x minus x squared. Very good. Okay. So now we are to calculate delta for this. We are to calculate the delta of um, of 2, pardon a minute. So we are to calculate the delta of minus x minus 2x plus 2. Is that okay? Okay, sorry, I placed the pause on the video. Okay, what you are going to do in such integrals, let me give you a hint, because this is a special case we've not seen, and I would like to give you some very important instructions on such types of integrals. Let me first wipe this. Whenever you are asked to integrate 1 all over the square root, remember it, whenever you are asked to integrate 1 all over the square root of ax squared plus bx plus c, whenever you are asked to integrate such an integral, this is the secret. This is the secret on what you are going to do. Complete the square. Don't even calculate delta. Whether you calculate delta or what, it will be the same approach that you are going to use. Complete the square of this. You complete the square of what is inside here. You complete the square of what is inside here. Complete the square of what is inside here using the completing the square formula, that is a into what? X plus b on 2a, all that square, minus delta on what? 2 all over 4a squared. Yes, that's it. So you use the completing the square formula. So we're first going to calculate delta. You understand? You use the completing the square formula. You see that if delta is greater than 0, this part will exist. If delta is less than 0, this part will also exist. But when delta is equals to 0, because when delta is greater than 0, it means this will have two real and distinct roots. When this is less than 0, it means this will not have real roots. When delta is equals to 0, all of this will become 0, and we will be left with something of the form a into x plus b all over what? 2a all that square. You understand? And you see that this square root will kill what? This, and you'll be left with what? Square root of a into what? X plus b on 2a, where this is a linear function. You will basically know how to interpret it. You understand? So take note of this type of integrals, because what we saw last time, what we saw in some previous videos, was how to integrate a on what? Ax squared plus bx plus c dx. I gave you the basic hints, but we did not see how to integrate square root of this. So whenever you are to integrate such a thing, the first thing you are supposed to do is, 1, calculate delta. You calculate delta. So let me take the pen. Let's calculate delta. Our delta here will be equals to what? B squared minus 4ac, which is equals to, our b is minus 2. Minus 2 squared minus 4 into a. Our a is minus 1 into what? C, 2. So this implies our delta will be equals to what? 4 this and this plus 8. So this implies delta will be equals to what? 12. So you basically see that delta is greater than 0. So naturally, this will have two real and distinct roots. Now, after doing this first step, I'll call this one step 1. After this first step, the next step is to let's find the completed square form. Let's find the completed square form. Let's find the completed square form of let's find the completed square form of let's find the completed square form of what? Of minus x squared minus 2x plus 2. Okay, very good. Let's find its completed square form. Recall that we know that ax squared plus bx plus c in completed square form, it is identical to what? A into what? It is equal to, let's write equal, it is equal to a into what? X plus b on 2a squared minus what? Delta on 4a squared. Very good. Let me verify. I hope that's it there. Let me check. Where is that for? Okay, this is it. This is the formula. Very good. Okay, let's continue. Now, this implies our minus x squared minus 2x plus 2 will be equals to what? Our a is what? Our a is minus 1. So minus 1 into what? X. Our b is what? Minus 2. Minus 2 all over what? 2 into a. Our a is minus 1. Our a is minus 1. All of this square minus, what was our delta? Our delta is 12. 12 all over 4 into, our a is minus 1. Minus 1 squared. Okay, very good. So this implies our minus x squared minus 2x plus 2 will be equals to what? This minus 2 divided by this minus 2, it makes plus 1. You understand? So I'll have minus 1 into x plus 1, all that square, minus minus this 12 divided by this 4 gives 3. So I'll bring in the minus 1 inside. This implies minus x squared minus 2x plus 2 in completed square form will be what? 3 minus x plus 1 all that square. So we have already written this in completed square form. So the step 3 will be now, the step 3 will be to find our integral that was given. So the integral of 1 all over 6 minus, don't forget that there is a 1/3 here, be very careful. So the integral finding the integral of 1 all over 6 over the square root of 6 minus 6x plus 3x squared. I hope that's it. Let me verify. It's minus 3x squared. Okay, very good. Dx. So the integral of 1 all over the square root of 6 minus 6x minus 3x squared dx, we saw up here that it was equals to what? 1/3 integral of this dx. Is that okay? So that would be 1 on root 3, pardon, 1 on root 3 integral of what? 1 all over the square root of 2 minus 2x minus x squared dx. But we know that this what is inside here, its completed square form is this. So this will be equals to 1 on root 3 integral of what? 1 all over what? The square root of what? 3 minus what? X plus 1 squared. What do you see, dx? What do you see? What can you notice about this integral? You see that this integral is already like 1 all over what? A what? A minus bx squared. The thing is that what is our problem? How do you integrate this? You know already that here, if there is no minus square root, pardon, there is square root here. You know already that to integrate this, if there is no minus 1 outside here, naturally the substitution you are going to use will be what? Sine theta being equals to what? So you write back this in which form? 1 all over the square root of 1 minus something all that square dx. You understand? So the first thing we have to do is what? We have to make this to become 1 for it to resemble this. And what will be left outside here, we shall bring it inside for nothing to be outside. You get what I'm saying? So let's go to the next page. Let me create another sheet of paper. This is 50. This is 51. Okay. I'm on page. Okay, let's continue with this integral. So this will be equals to, let me first copy the integral. So the integral, wait, let me wipe it. So 1 on the root 3 integral of 1 all over 3 minus over the square root of 3 minus x plus 1 square dx will be equals to what? So what we have to do, we first have to make this to become 1. So we factorize 3. This will be 1 on root 3 integral of what? 1 all over, I'll factorize 3 here. I'll be left with 3 into 1 minus, since there was no 3 here, this becomes 1 on 3 into x plus 1 square. Close the bracket, dx. Okay, let me bring this, because this is root a times root b, which is equals to root a times root b. Is that okay? So I will apply it here. This will be equals to 1 on root 3 times 1 on root 3, because there is root 3 here. Integral of what? 1 all over what? The square root of 1 minus 1 on 3 into x plus 1 all that square dx. Is that okay? Now, what we have to do is what? We have to bring in all of this inside here. So we're going to use our technique that we usually use. This times this, if you have a on b times g on c, to multiply this, you just do the multiply the numerators and multiply the denominators. So this becomes a on d over what? B on c. So this will be equals to 1 root 3 times root 3 is 3. Integral of what? 1 all over the square root of what? 1 minus root 3 root 1 on 3 square times what? X plus 1 square. Is that okay? Let me close the brackets here. Is that okay? Because if you square this, this comes back to this. Now, I'll bring this, since they are this and this are having the same power, I'll then bring this inside, because a to the n times b to the n is equals to a times b to the n. That's the law of indices. So this will become, sorry for the video is already a bit long, but it's important for me to explain clearly things inside here. So this 1 over 3 integral of what? Let me write my dx here. Integral of wait a minute, integral of 1, let's say dx all over the square root of 1 minus, so I will have here x plus 1 times what? Notice that root 1 on 3 is the same thing as the square root of 1 over the square root of 3, which is simply 1 all over root 3. So 1 all over root 3, so this will be all over root 3, all that what? Square, and I close the brackets here. Is that okay? Is that okay? Now, we have already something of the form. So it's already in which form? 1 all over the square root of 1 minus all something squared dx. So we naturally know that since there is no minus here, then substitution will be what? Sine theta being equals to what? All what is squared. So that's what we're going to do. So I will let sine theta be equals to what? X plus 1 on root 3. So where we see x plus 1 over 3, we shall substitute by sine theta. What will be dx then? We have to find it by differentiating this implicitly. When I differentiate this, I have what? Cos theta. Since I was differentiating with respect to theta, I write d theta. This will be equals to what? Don't be afraid of this. This is simply the same thing as what? Differentiating what? I'm simply differentiating 1 on root 3 into x plus 1. Is that okay? Or you simply write it as what? X on root 3 plus 1 on what? Root 3. Is that okay? So when I differentiate this, when I differentiate this with 1, I'll have 1 on root 3. Since I was differentiating with respect to x, I multiply by x. When I differentiate this other one, it's 0. Multiply by the x, that will give 0. So this implies dx will simply be equals to root 3 times what? Cos theta times d theta. So we have already our dx. Let's substitute things. This implies 1 on 3 integral of dx all over the square root of 1 minus x plus 1 on root 3 all that square. Let me close the brackets here. Will be equals to what? 1/3 integral of what? My dx is root 3. My dx is root 3 times cos theta d theta. Is that okay? All over the square root of 1 minus, we let this part was equals to what? Sine theta. So we are going to have here, there's a square here, sine square theta. Is that okay? Now 1 minus sine square theta is what? Is cos square theta, because sine square theta plus cos square theta is 1. So 1 minus sine square theta is simply equals to cos square theta. And with this square root, we are going to have the square root of what? Cos square theta, which is what? Cos theta. So this will be equals to 1/3 integral of root 3 cos theta d theta all over what? Cos theta. The cos theta will go, and I'll be left with root 3 on 3 integral of what? D theta. This is simply equals to root 3 on 3. Integral of d theta is theta plus our constant, let's say c4, where c4 belongs to the set of, let's call it c4, where c4 belongs to what? The set of real numbers. But our sine theta, the integral is in terms of x, so we'll have to leave it in terms of x. But our sine theta was equals to what? X plus 1 on root 3. But recall, our sine theta was equals to x plus 1 on root 3. This implies theta will be equals to what? Arc sine of what? Arc sine of x plus 1 on root 3. Is that okay? So where we see theta, we substitute by arc sine of what? X plus 1 over 3. So it then implies the integral. It then implies, what was the integral we were looking for? Let me go on in this page. It was the integral of 1 all over 6 minus 6x minus 3 x squared. square root of 6, integral of 1 all over the square root of 6 minus 6x minus 3x squared dx. Okay, so it implies the integral of 1 all over the square root of 6 minus 6x minus 3x squared dx will be equals to what? Root 3 on 3, my theta I replace by this, arc sine of what? X plus 1 on root 3 plus our constant of integration C4. So that's the integral. That's how it was simple. So what I want you to remember on this last exercise we did is that whenever you are asked to integrate square root of ax squared plus bx plus c, whenever you are asked to integrate that, what is inside the square root here is a complete quadratic equation. Whenever you are asked to integrate such a thing, the first step is to do what? You calculate delta. The next step, the step 2, you write your ax squared plus bx plus c in completed square form. And the last step, step 3, you integrate using all the techniques that you were being taught in the previous videos. Let me also emphasize on something. Let's say you were asked to integrate 1 all over the square root of x plus 1 into x plus 2. How are you going to integrate this? Let me see how you are going to integrate this. How are you going to integrate this? Put a pause and try to integrate this. It's very simple. I hope you tried it. So it's very simple. What you do is what? When you multiply these two equations, these two linear expressions, what are you going to have? You are necessarily going to have a quadratic expression, ax squared plus bx plus c. You see what I'm saying? So after multiplying these two, you will be in a situation where you are basically integrating what? Something of this form. So you just apply these steps. Is that okay? You just apply back these steps. Step 1, you calculate the delta. Step 2, you write this in completed square form. And step 3, you integrate. You just do the integration as we just did. Is that okay? So this video was long, more than an hour, but it was very important for me to emphasize. So that marks the end of integrating rational functions that will give rise to trigonometric inverse trigonometric functions. So in the next video, we shall basically see how to integrate. This is the last type, the type 4, on how to integrate rational functions. So we shall basically look at this first one. I'll give you the hints. So I'll explain how to integrate this and how to integrate this. And in another video, we shall see exercises. So see you in the next video. Try to go through this video. I know it was a bit long, but it's very important. It's very important video. Try to go through this video, and you have to do this last one. Yes, this last one. Try to do all the to redo the exercises and do this last one. If you face difficult, but I don't think it will be something very difficult for you. So try to do them, and see you in the next video. Good luck.